So what is normalization in database? Normalization in database is the process of structuring a relational database in accordance with our series of so-called normal form, which is they have one NF, second NF, and third NF. So for the next topic, we go to Luis. So for Luis, time is yours.
Explain about the first NF and the second NF, the first normal form and the second normal form. So for the first normal form, there is wait, sir.
Next, yes.
From what I read from the session 12 model for the first form, there is a request for the table satisfies as a following condition, which is the row are not ordered and column are not ordered, and there is a duplicate data, and the row and columns intersection always have unique value, and all the columns are regular. For the second form, which I read and I have learned, the second form, the second normal form, we need to find the partial dependency on each on the table, and then we separate the table into we use only one partial dependency on all of the tables. So there is only one primary key on each tables for the second NF, the second normal form. For the third normal form, I'll ask Rafi to explain. Please, Rafi.
Rafi?
Okay, I will describe about three normal form. The three normal form it has a requirement. First is the data must be in 2NF first, and the record or the data of the column should only has one data. So for the third NF normalization, we should separate the data into other table and make them connect in the base table. If we look in the module, we can see the data is separate from the first data. So, and it separate in three table. Yeah, that is the first data, and in the below the table, we can see that the data is separate according to their key or the column name. After 3NF, we should know about why we should do normalization. Sometimes we insert same data and it will make the data it will make our computer somehow lagging or how to say it, slowly. So the normalization is a way to encounter this problem using several steps like 1NF, 2NF, 3NF. Actually, the normalization is until 6 normal form, but the 4 normal form, 5 normal form, and 6 normal form is more harder, and it doesn't impact in the database. I think that's also about this module. It's about 1NF, 2NF, and 3NF, and how we do normalization and why we should
Why
do
we should normalization?
normalization. I think that's all for us. Thank you.
Okay.
Sir, can you see my screen?
Yes.
Yes. Okay, right now we will present our discussion about normalization. Okay, first I will tell you about normalization. Normalization is just like we convert a normal form table like this into a higher degree. Into a higher degree, we call it a normalization. But if we convert it into a lesser degree, we call it as denormalization. For normalization, uh, we do normalization because we can avoid redundancy. We can minimize the redundancy. Okay. So for first, we can see in this normal form there is something that failed to meet the first NF or first normalization form criteria. We can see it here. From this highlighted place field, we can see it. For first normal form, all data is atomic or all table columns contain identical values. We can see it from the highlighted field that there is a multi-value data here from the address, and then we have to avoid this we to make all the data is atomic and all table contain identical values. All for the identical values we already have it for invoice number, customer number, and I invoice item number, but we have to make the data atomic, or we have to divide the multi-value data into this. From this address we have 30-foot Woodland Springfield MA or 044X7. We have to divide it into a new column like this: a street address, city, state, and zip code. And after that we have to change it or convert it again to a two normal form. For two normal form, the criteria is its non-key attribute must be fully functional, dependent on the primary key. Uh, in this highlighted field, there is a super key. It's a key that allows you to uniquely name the individual lines of a database table. But for this second normal form, we just need two candidate key. From the super key, we have to we just need two candidate key to represent the table. We can see it here. The invoice number and invoice item number is the candidate key, or we can say it the primary key for each table. Okay, we can see it here for invoice table. We can see the primary key or the invoice number key represent for the table invoice, and then invoice number invoice item table. You can see it, the invoice item number is the primary key for invoice item table. Invoice number here is the foreign key. Foreign key. Okay. Oh yes. Before that, when we want to create a table, we have to find the related columns. For for example, invoice number, it's related with the date, the first name, last name, customer number, street address, and city. and then the other, or the zip code, product number and price, we have to separate it into a new table for the primary key invoice item. Uh, Here we can see it again, invoice number as the primary key for the invoice table, and an invoice item is the primary key for the invoice item table. Okay, next, for the third normal form, Nikki will present it for all of you.
1 minute. I'm going to stop my sharing.
So
Okay,
I will
next.
continue the presentation from Eric and start from the third normal form. When you start the third normal form, you must have the second normal form, and before that you must convert it into a first normal form. In the third normal form, no non-key attribute may be transitively dependent on the key candidate. Transitive dependency occurs when a non-key attribute is dependent on another non-key attribute, and so indirectly on its key candidate. In the invoice table, the first and last name and the street address, city, state, and zip code depend not only on the primary key or the invoice number, but also on the customer number. As you can see on the table, that invoice table. And for the next table is the invoice item. In the invoice item table, the product and price attribute depend not only on the primary key, derived from the invoice number and invoice item number, but also on the product number. As you can see on the table from invoice item, and to remove all dependency between non-key attributes, the relevant attributes have been moved to separate table, linked to each other by foreign keys. This results in the four normalized table: invoice, customer, invoice item, and product. The primary key of the invoice table is sequential invoice number. Each invoice number is assigned a date of invoicing and a customer number. And we can see on the invoice item table is a central table in the sample database containing information about which product should appear on which invoice, as well as how many items were ordered. The sequential primary key on the invoice item table is derived from the invoice number and the invoice item number. And finally, the product table contains detailed information on the respective products, such as the product description and price. The primary key is the product serial number. As you can see, the highlighted column. And just for your information, duplicate values in relation database are often unavoidable. In reviewing the example as its conversion unfolds, it's evident that the linking of database tables by foreign keys can be connected with redundancies. These are known as key redundancies.
Okay.
So back to Eric, maybe to close the presentation. Eric?
Genoveva, please. Veva, please. Veva.
Zeno, Eva, are you here? Where is
Okay.
Yeah, sure.
Yeah.
So for the freeze, I'm say sorry because in our country now our network is not working very well, and so I
Yes.
cannot hear very well. And
Yeah.
so
I think Eric's just closing.
Okay, I will close it. Okay, that's our presentation
okay, so
for the.
that's so so that's all our presentation today about the normalization about the database normalization. So here my friends Eric and Octave already explain about that, and so that's all our presentation, and thank you so much.
Thank you. Thank you.
Then